Hi everyone, let's solve the LeetCode problem number 41, first missing positive. So let's read the problem statement. So given an unsorted integer array nums, we need to return the smallest missing positive integer. Okay, and we have one constraint here. You must implement an algorithm that runs in order of n times and uses constant extra space. Okay, makes sense. So let's try to understand the problem statement clearly using some example. So let's take the second example. 3, 4, minus 1 and 1. So clearly the nature of the array we can say like it's unsorted. That is also explicitly mentioned in the problem statement. We would be given an unsorted integer and nums. Okay, and we need to return the smallest missing positive integer. Okay, so the positive integer range could go from 1 to 3 up to n. And if you see in our array that is given to us, 1 is present. Okay, but 2 is not present here. So for this input, we are going to return 2. Let's take another example, 7, 8, 9, 11, and 12. So for this one, if you see like 1 is not present, and that is the smallest missing positive integer. So definitely like 2, 3, 4, 5, and all these numbers are also not present here, but 1 is the smallest missing positive integer from this array. So for this input, we are going to return 1. Okay, hope you understand the problem statement better. So let's try to come up with some approach to solve this problem. But before doing that, let's try to forget about this constraint and try to think like, is there any approach through which we can solve this one? And we are not considering this case like we need to solve it in order of n time, and we have to use the constant extra space. So the approaches that could come to our mind, let's try to write it down. So the first approach could be simply using hashing technique. So under hashing technique, what we will do or what we can do, let's say like I have this integer array. So I will use hash to store this element and to perform the quick lookup. So let's say like for this array can contain positive, negative, and zero. I will just insert all the positive elements only. So let's take the first example. I would insert 1 and 2 in our hash set. Okay. And now we know the positive integer starts from 1 and it could go up to n. Okay. So as soon as like we find the element that is present in this array, we are good. Okay, we'll start from 1. Let's say like I have one variable positive number. So as soon as like we find it in this hash set, we are good. We can increment our positive by 1. So next I will try to look up for 2. 2 also I find. So next I will try to look up for 3. But 3 here I didn't find. So I am going to return 3 for this input. Okay, let's take some another example to understand it the approach clearly. So here we can see like we have positive and negative numbers. We could simply insert only positive numbers, and again we will start from 1. So I will start looking like, yeah, 1 exists here. I increment its value by 1. 2 doesn't exist here, so that's why we are going to return 2 for this input. Okay, so let's discuss the time and space complexity of this approach. So here if you see with respect to the time complexity, what we are doing, first we are iterating the array and inserting all the positive numbers into this hash set. Okay, so for that one the time complexity would be order of n. And next time what we are doing, we are simply going from 1 till the point where we find the first smallest missing positive numbers. Okay, and we are doing the quick lookup in this hash set. Okay, so for performing the quick lookup, the time complexity would be order of 1 since we are using hash set. So that would allow us to do the lookup in order of 1 time complexity. And we are just starting from 1, and until and unless we find the one smallest positive missing integer, we would stop there. But in worst case, let's say like our input is given something like this, our array size is 4 and we have been given input like this, then in worst case it could go up to n, and at then we'll just return 5. Okay, so overall time complexity for this hashing based approach would be order of n, and space complexity would be order of 1, considering the scenario where we have all the positive numbers present here. Okay. So yeah, we understand one approach using hashing technique. So hashing technique is a standard technique that you can utilize in solving multiple problems. So that's why I'm just discussing all these things so that you can utilize the same technique to solve any other kind of problems also. The approach to that would come to our mind is using sorting. So the steps would be sort the array. Okay. And as soon as we sort the array, then yeah, first negative numbers, then zero, then positive numbers. Okay. And we know the smallest positive number is one, so we'll start comparing. We'll first iterate in this array until and unless we find the first positive number, and we'll start comparing. If these are same, the number that I am currently processing and it's equals to the value one, then we are good. We'll just increment its value by one, and we'll start looking for the next element. And as soon as like we find first point where this is not matching, I will simply return this value. Let's take one example to understand this one. So let's take this 3 4 minus 1 and 1. So when we perform the sorting, we could have this arrangement. Okay. So now first in my array, I will start traversing and I will stop until and unless I find the first positive numbers. So I will just skip this one, and let's say like I have multiple negative numbers, then I will just skip that one. And even if I have zero, I will skip that one, and I will start processing the actual processing from this place. Now let's say like in some variable, like missing positive, I am storing missing number. I am storing or initializing because I know the smallest missing positive number or smallest positive integer is one. I will start comparing. They are matching. It's good. We'll just increment it's by one, and it's also by one. Now I will check like these are not matching. Then in that case, I will just return two. Okay. Let's take one more example where we have input like one, two, three, four. Okay, and it's already sorted, so we can ignore the sorting part and we come here. And if it is not sorted, then first we need to perform the sorting. Then I will get the elements in this order. I will start comparing now. Missing number that is stored in one variable. I will compare. It is matching. Perfect. Increment its value by one and increment the pointer also by one. Again, it is matching. Perfect. Increment the counter by one. Again, it is matching. Perfect. Increment the counter by one. And we are done with the iteration. And at the end, I will just return this number. That is 5. So hope you understand the second approach also. So for this second approach, let's discuss the time and space complexity. So here, like first we are performing the sorting, and after that, like we are doing the standard iteration. So for performing the sorting, the time complexity would be n log n. Let's say like I'm using quicksort or mudsort to perform the sorting, and definitely like we are going to use the library version or library to perform the sort operation. Then in that case, is the worst case time complexity would be also of order of n log n. So space like time complexity for performing the sort operation is order of n log n, and after that we are just iterating the array. So for that one, it's order of n. So the total time complexity would be order of n log n plus n, that is order of n log n. And space complexity, let's discuss about the space complexity. If you see the space complexity, then we are not using any extra space. So the space complexity would be order of one. Okay. So here we discuss the sorting technique also. It's the same way like you can apply the sorting technique to solve multiple other problems also. So now, definitely like these two approaches that we have just discussed will not satisfy this constraint. Like we have to solve this in order of n, and we have to use the constant extra space. Even the hashing approach that we have discussed, we are using order of n extra space, so that would not work. So let's try to come up with an approach that would satisfy both the constraint. Time complexity would be order of n, and space complexity would be order of 1. So definitely, like if we have a constraint like this one, or a strict condition constraint like this one, like we have to use the constant extra space. Then in such cases, what we can do, like we have to use the existing given array. We don't need to create any array or any other data structure to store the element. We'll start utilizing the given array itself to perform the operations. And now let's discuss like how can we use the existing array to store the element and figure out the first missing positive numbers. Okay. So for that one, like what we can do, like given any array, Like it could contain negative numbers, zero, and positive numbers. And like this is not sorted, so it could be unsorted also. Just for representation purpose, I have drawn it like this one, and you can treat it as a sorted one. Okay. So what we can do, definitely, like we are not interested up to this part, the negative numbers and zero. We are just interested in the positive part. So if we, because like this will only help us to get the result. So first what we can do here, like I will try to segregate the positive and negative numbers. We don't need to maintain any kind of ordering, like increasing order or decreasing order. Even if you perform the sorting, then we segregate the negative, positive, and zero. But if you perform the sorting, the time complexity will be order of n log n. That would violate the constraint that we are having here. So I will just use the standard technique or standard way or standard iteration to segregate positive and negative numbers. And if we are able to segregate positive and negative numbers, something like this, like let's say like I segregated this something like this, 3, 4, 1. Okay. So for that one, like you can use the standard technique of finding the partition in quicksort. So in quicksort also, like we choose one pivot, and after that like we try to split the array in such a way like all the elements that is lesser than this pivot will reside on the left side, and all the element which is greater than this pivot would reside in the right hand side. The same logic we can apply here to segregate this positive and negative numbers. And after that, what we can do here, like we know the range, this positive part, we can simply skip up to this part. We know this positive numbers range, and here we can do the in-place hashing. So by in-place hashing, I simply means like we already know, like we need to return the smallest missing positive numbers. So whatever the size of this positive numbers range, let's say like it's currently 3. So we'll start utilizing this array of size 3 only for performing the hashing. So here let's say like I have one based indexing. So first element here I see like one element, first element is 3. Then at index 3 I will go and simply mark it as let's say like we are marking it negative. Okay. So I'm just changing its value to -1, something like this we can do. Okay. But here also like we need to be conscious. First let me explain the approach, and after that we can discuss how we can achieve this. So let's say like we have this, then at a third index I will go and simply mark it for it is out of bounds, so we don't need to process it, or we don't need to consider it. And first we can go. And I will start iterating this array, and as soon as like I find any element which is having value as 0, then I will just return that index. Okay. Let's say like all elements are present. We have 1, 2, 3. Then in such cases I will just return this whatever size of this one plus 1. Let's say like this size is n, then n plus 1 would be our answer. Now let's stick to how we can do the partition. So we just understand like we need to partition the array. Partition array. By partition, I simply mean segregate positive and negative numbers. Positive and negative numbers. And second part is doing in-place hashing. Okay. So let's try to deep dive into each of the steps one by one. Let's first focus on this part. So let's say like I have this number 3, 4, -1, 0, and we are just interested in storing the positive number. So what I will do, I will start utilizing the same space. Let's say like I have variable id, and here like at corresponding index the elements are present 3, 4, -1, and 1. So the first element is positive. Okay, perfect. So I will just go ahead and put it at the index 0. Okay, so at index 0 earlier also like this element is only present. At 4 also like I see like the element is positive, so I will just go ahead and update at index 4. At -1, this is a -1, definitely like we are not interested in this one, we can simply skip. This is also a positive number. At index 2 I will just go ahead put it. We are done here with the processing of the array, and we know the positive array size range that would be of this size from 0th to this index. We have all the positive numbers. For the remaining numbers we don't worry. Like let's say like here also like 1 is present because we have not updated its value, but here like we'll just stick to this range, and nothing less or nothing more. So now here, like we have performed the partition, now we'll just apply the in-place hashing. So for performing the in-place hashing also, so what we can do here, 3, 4, 1. Okay. Let's assume like we have a zero-based indexing. Okay. Then in that case, what could we could do? first element I am seeing like it's 3 and it is out of range because we have just we can simply ignore that one. Second also like we see like we can simply ignore that one. First one what we can do here, I see like at index 1 we should go and update it. So let's say like I am marking it -4. Okay. So instead of performing the zero based indexing, I see like there could be multiple challenges here. We can perform the one based indexing. So let's say like I have this number and we have this like, so for 3 I will just go at this index, I will mark it at negative. 4 that is out of range, we are not interested. For 1 also like I will go ahead and I will mark it negative. Okay. So to fetch here definitely like whenever we are getting any value, let's say like array I am getting and putting it in some variable I and b, then if it is negative we need to make it positive. So what we can do like we could take the mod of this one. Okay, because we know like these are all the positive numbers and we are just marking it negative so that we can understand like yeah this element is present or the element at that represent this index like 3 is present. So just to illustrate or represent this one like we are doing this negative thing. So yeah, now I will just start from here, and as soon as like I find the first positive numbers, then I will just return that corresponding index. So for this input, we should return 2. So yeah, that's the approach. I hope like you understand the problems. We have discussed three approaches to solve this problem, and the last one is the only approach that satisfies both the constraint. Like we are having a time complexity of order of n and space complexity of order of n. So yeah, that's all I have from my end.